Good morning, everyone. So this video is all about the exercise 3. It's nothing but the IP addressing and subnetting in your computer communication networks. So what are the topics which are to be covered in IP addressing and subnetting which includes the class identification. So first of all, when an IP address is given, we need to find the class, to which class it belongs to. Then the next is the network address. So from an IP address, we can differentiate between the network as well as the host. And then comes the host address. Then finally, we will be dealing with what is meant by default subnet mask and what is meant by custom subnet mask. And finally, we can have an example program in order to have a clear view of how the particular IP address is being differentiated into the network address and the IP address, and how are we gonna calculate the total number of subnets and the total number of hosts from the given IP address. So first, we need to know what is an IP address. So an IP address is nothing but the unique address which is given to a device. So when a particular IP address is given, first of all, we need to find to which class it belongs to. So we have altogether 5 classes, that is class A, class B, class C, class D, and class E. So we usually make use of 3 classes. So they are class A, class B, and class C. So usually an IP address, it is of 32-bit long and it consists of 4 octets, each of which can contain 1 or 3 digits, which is ranging from 0 to 25 separate single dots. And the IP address can be further divided into 2 parts, so which is nothing but the network ID and you have the host ID. So if you want to calculate the number of networks, we can power the number of bits, that is 2 power the number of network bits will give you the number of networks. And in the case of number of hosts, 2 power the host bits minus 2 will give you the number of hosts. So now let's see some of the features of class A. So the class A ID, that is the network ID, will have 8 bits. That is the network part of that particular ID. That is the class A ID will have 8 bits. And the host ID, it will have 24 bits. So here we can see the view of how does the class A look. So usually it consists of, it usually starts with 0 and the network bits are 7 bits and the host bit is 24 bits. So this is nothing but class A. Now we have the class B address. Suppose if an IP address which belongs to the class B, then the network ID will have 14 bits and the host ID will have 16 bits. And usually the subnet mask will look like 255.255.0.0. For the class A, it is usually 255.0.0.0. But for the class B, it is 255.255.0.0. So here, the network ID and the host ID is being calculated, as you can see in the PPT, the presentation. So where here the network ID is 2 power 14, where you get 16,384 network IDs. And here the host ID is 2 power 16, where you get 65,534 host IDs. So this is the view of class B network, that is into class B ID, where you have 14 bits for network bits and 16 bits for host bits. Usually it starts with 1, 0. Now let's discuss about the class C. So here the class C, here you have the network ID has 21 bits and the host ID has 8 bits. And the default subnet mask of the class B address is 255.255.255.0. So we can calculate the network ID as 2 power 21. That is equal to some value we get. And the host ID is 2 power 8. For that, you get a value. So this is class C. Now we have the overall visualization of class C. So usually it starts with 110. And here the network bits, it includes 21 bits. And the host bit includes 8 bits. So this is class C. So also we have ranges for class A, class B, class C. So as here the class C, the ranges, I mean, if you have the bit, I mean, if you have the ID, which has 192.168.2.1, then that 192, it lies within the range class C, because the class C, it ranges from 192 to 223. So that is how we are finding the class of a particular ID. Then comes the class D. So the class D, it has 4 bits. and the IP address which is belonging to the class D, it ranges from 224.0.0.0. So this is a different case. That is nothing but the class D. So this is the visualization of class D. Then we have class E. So in class E, usually the IP address which is belonging to this class E, it has like mainly this class E, it is used for future use. So mainly it ranges from 240.0.0.0 to 255.255.255.254. So this is the class E, where you can see it starts with 4 ones, and you have the host bits that includes 28 bits. So here we can have a pictorial representation of how the network address of each class, how does it look, and the host address of each class belongs to. So now we have the class A, where you have the network which consists of 8 bits. That is, we have 4 separate octets. We call those 4 parts which is being separated by dots are called as 4 separate octets. And each octet has 8 bits. Now, the IP address which belongs to class A, it consists of 4 octets, where the first 8 bits belongs to the network and the other 3 belongs to host. Now, when we are coming back to class B, the first 2 octets, that is the first 2 octets, actually it belongs to the network. Then the next 2 octets, it belongs to the host. Now, when compared to class C, when we come back to class C, we have 3 network portions and 1 host part. So the 3 octets of the IP address, it belongs to the network, and 1 octet of the IP address, it belongs to the host. So this is how we classify the class A, class B, and class C. Now, how do we calculate the default subnet mask? Usually, the default subnet mask for class A is 255.0.0.0. And for the class B, it is 255.255.0.0. And for the class C, it is 255.255.255.0. So this is how we can make a differentiation between class A, class B, and class C. So now how are we going to calculate the custom subnet mask? So in the later examples, I will tell you how to calculate the custom subnet mask. This is just a pictorial representation of how the IP address looks and how a subnet mask will look, and how an IP, how can we, from the subnet mask, the IP address, how can we calculate the network ID? And so we have the IP address, for example, we have 172.16.2.200. And the default subnet mask for that is 255.255.255.0. Now, how does the network ID look? That is 172.16.2, the 3 octets will belong to the network. So it is called as the network ID. And the 0, it denotes the host ID. So this is how the network ID is being found from the IP address and the subnet mask. There's the same example is being given. So now let's get into the example problem. So here in this example problem, we have an ID. So for example, we have an ID, that is the IP address of a particular device is 192.168.1.0. Now this default, that is the default mask, the subnet mask which is being calculated for that IP address is 255.255.255.240. This 240 is nothing but the custom subnet mask. So that is what we have to calculate. So that comes under the calculation part. And /28. This 28 is the number of bits in each octet. So 28 bits will be present in each octet. So as we see below that particular subnet mask, we have 1, 1, 1, 1, 1. So we have 8 ones in one particular octet. And we have other 8 ones in another particular octet, another 8 ones in another particular octet. And we have 4 ones which belongs to the host. So what is the problem is, we are trying to calculate, that is the subnets, the number of subnets from the host part. We can always calculate the subnet from the host part. So we have to calculate the total number of subnets and the total number of hosts, and we can also calculate the total number of valid hosts from this particular IP address. So first of all, we should know to which class does this particular ID belongs to. So obviously it belongs to class C, because that particular number 192, it lies within the range class C. Now, as /28 is given to the subnet mask, we can give 28 1 bits. So there are 4 ones and 4 zeros in the last host part. So we can calculate the subnet is equal to, it's always the calculation begins like this. It is 2 power how many number of subnets, that is how many number of bits, that is the 1 bits are there in the host part. So there are 4 1 bits. So we can give it as 2 power 4, that will give you 16. Then how many number of hosts are present there? Usually there are 4 hosts, that is 4 bits. That is we have to calculate the number of valid hosts, that is 2 power 4. That is the number of total hosts, that is 2 power 4, that is 16. And if you want to calculate the valid host, you have to just subtract with 2. So 16 minus 2 will give you 14. So this is how you should calculate the total number of subnets and the total number of hosts. And from the total number of hosts, we can calculate the total number of valid hosts. So this is a very good example for finding out the class of the particular ID. And we can calculate the total number of subnets. We can calculate the total number of hosts, and we can calculate the total number of valid hosts from the total number of hosts. So here, let us see another example. So here, another example, actually, we have, so I'll just try to, so I will just show you the last example. So this is the last example which I just wanted to show you. So here we have the class C. So here the class C, so here we have an IP address which belongs to class C. Now you can see this host part, that is 256.128.64. It's nothing but it is the power of 2. So 2 to the power 2 is 4. 4 to the power 2 is 8. 8 to the power 2 is 16. 16 to the power 2 is 32. 32 power 2 is 64. 64 power 2 is 128, and 128 power 2 is 256. So this, it belongs to host. Now to coming to the subnets, we can just calculate from left to right. So it comes as 2, 4, 8, 16, 32, 64, 28, 256. So you can just have this particular type of numbers in a separate rough sheet so that it will be easy for you to calculate the other problems. So now the last line, it indicates that 1 is 2 and 2 plus 2 is 4. So 4 plus 4 is 8. So 8 plus 8 is 16. 16 plus 16 is 32. 32 plus 32 is 64. And 64 plus 64 is 128. So this is the addition. It indicates actually the number of bits. The number of bits. And the first line, it indicates the host part. And the second line, it indicates the subnet part. And the third line, it indicates the number of bits. So now we have to calculate the problem which is given is, we have to calculate the number of needed usable hosts. That is the valid hosts. So the problem they have given it as 25. So now the network address which is being given is, so a few network addresses be given. Now we have to calculate the particular IP address, to which class does this particular IP address belong to. So it belongs to class C because it ranges from 192.256, that range, the 257 number, actually it ranges between the particular number 192.256, which belongs to the class C. Now we have to calculate the default subnet mask. So usually for the class C, you can write the default subnet mask as 255.255.255.0. Now we have to calculate the custom subnet mask. So before we calculate the custom subnet mask, we can calculate the total number of subnets. So the total number of subnets, how are we going to calculate the total number of subnets? So here we have the subnets, but the given number of valid, that is the usable host, is 25. So we should see in which range, which number is very close to 25. Okay. So while we are calculating the host, usually what we do is we calculate the 2 power of the number minus 2. So when we calculate the 2 power of that number minus 2, so when we take 16, so we have 2 power, the number 16 minus 2 will give you 14. Okay, so it's actually 16. We have to minus 2. So it will give you 14. So 14 is not, which is very near to this 25. So what happens? We are taking 32. So when we are taking 32, we can draw just a line between 64 and 32. Now you just imagine particular host 25, it lies between 64 and 32. Now we can just draw a line between this. Now we can calculate the total number of subnets. So the total number of subnets will always lie in the second line, which is to the next of the line which we have drawn. That is to the left of that line. So here it is 8 bits. So the total number of subnets will be equal to 8 bits. Now what is the total number of host address? So the host address will always lie in the first line, which is to the right of that particular line which we have drawn. That is imaginary line. So which is nothing but 32. So that is the total number of, so 32 is the total number of total address. Now if we calculate the number of usable host address, we have to minus 2. So 32 minus 2 is equal to 30. So the total number of usable address is 30. Now the number of bits which are borrowed, that can be calculated in the third line. So the third line, it indicates the number between 64 and 32. It means there should be a line between 32 and 60. So how many number of bits are present in the leftmost side of that particular line? So we have 128, 64 and 32. So it is 111. So 1 indicates 1, 2. So we have 111. So we have 3 bits. So the total number of bits is equal to 3. Now, finally, we can calculate the subnet, that is a custom subnet mask. So how can we calculate the custom subnet mask? The custom subnet mask can also be calculated from the third line, which is nothing but the number of bits. So as we already know that there is a line between, that is an imaginary line between 32 and 16. So now we have to calculate the exact bits, that is 128 plus 64 plus 32. That gives you a whole value, some values like, so how much? So 128 plus 64 plus 32 will give, it will be equal to some bits. So that bit will be equal to this custom subnet mask. So this is how we have to calculate the default subnet mask, the custom subnet mask, the total number of subnets, the total number of host address, the number of usable address, and the number of bits which is being borrowed for the particular IP address which has been given, and for the particular number of usable hosts, that is 25, which is already given. So this is how we come to know about the subnet mask and IP addressing. Thank you.